Welcome to HYB308. This is a session on migrating VMware workloads, and specifically with on-prem dependencies. If you are listening to us from Venetian, welcome. Thank you for joining. So today, we're going to cover basically, this session's going to have three different parts, but before we get into that, let me just quickly introduce myself. So my name is Mayur Devaikar. I lead product management for the hybrid compute solutions at AWS, and I'm joined by Brian Dougherty. Brian Dougherty is a principal solution architect, and he's one of our subject matter experts in edge computing. And then we have also Claudio Keist. He is our customer. They have a very exciting case study around migrating VMware workloads to AWS, and he's going to be speaking to us as well as part of this presentation. So we're going to try to leave some time for Q&A towards the end, but if we run out of time, we'll be around, so you can ask us questions in the hallway. So with that, let's dive in. So the agenda basically is broadly categorized into three parts. So I'm going to start out by talking about what are some of the drivers customers are thinking about for migrating workloads to AWS, and then what are some of the potential pathways that are available to customers. And then Brian's going to spend a lot of time talking about all the different tools and services that are available at AWS to help you migrate your workloads to AWS. And then Claudio's going to talk about the case study in a lot of depth on how they went about the migration, what are some of the benefits that they've seen after doing the migration to AWS. So when we talk about migrating workloads to AWS, I think it's important to start talking about first, like why are people considering this, right? So VMware has been around for a very long time. Very recently, VMware was acquired by Broadcom, and Broadcom brought about a lot of different changes in licensing. And that got a lot of people thinking, okay, so what should I do with the workloads I have now, right? Because a lot of customers were facing very steep licensing cost increases. And when we talk to customers, I think the motivation really kind of fell into two broad buckets. First one was obviously business drivers, right? So cost is increasing. There's potentially a risk of running workloads on a legacy platform, and customers are really looking to manage all of that through this transition. It also got people thinking, why don't I just think about like innovating and modernizing my infrastructure if I'm going to get out of VMware to begin with? And so that led to some really interesting conversations with customers. And a lot of customers were also looking to consolidate different systems, the different setups that they had, and they were like, well, why don't we look at cloud as an alternative to VMware, right? A lot of customers are also trying to become more sustainable in their data centers, right? So reduce their carbon footprint, and so moving to a efficient cloud-based infrastructure really helps you get to that goal. And then a lot of customers who were kind of going through M&A activities also came to us and they started talking to us. And it was interesting because with M&As, when you have all these different disparate systems, what AWS allows you to do is bring these all together in a seamless manner, right? So on the technical side, I think a lot of customers have accumulated a lot of debt over the years running on VMware workloads. And so they're looking to really improve their security posture, improve scalability and reliability of the setup. And a lot of customers also want to get out of data centers, right? Because they don't want to be in the business of managing infrastructure, managing data center. So the real value of coming to AWS is that we provide you the resiliency, the elasticity that you need from your infrastructure without really having you manage the infrastructure, right? So we want you to get out of the business of managing infrastructure. We want you to deliver applications, deliver value to customers, your customers, as quickly as possible. So those are just some of the drivers. So when you think about getting out of VMware and coming to AWS, there are a lot of different options available, right? So I'm going to break this down. There's two potential pathways, right, at a high level. The first is you can just go to the region. So go to the cloud, and in the cloud, you have, if you're running let's say, VMware workloads on VMware Cloud on AWS, and you need some time to figure out what to do with those workloads, Broadcom is going to continue to run those workloads for the foreseeable future, right? So you can take your time, you can decide what you want to do with it. A very easy way to get out of VMware is lift and shift. It's being done for a long, long time. Last 10, 15 years since AWS has been around, customers have been taking their VMware workloads and moving to EC2. And that's a very, very low cost and low effort exercise to get to the cloud quickly. Beyond that, you can re-platform your workloads, you can move into containers, you can go to managed databases, and then if you really want to get very fancy, right? Let's say you wanted to go completely cloud native, you can completely re-architect and refactor your applications and move to modern technologies, let's say like serverless, right? So you have all of these different options. So depending on how much ROI you're looking for, how much time you have, you could use one of these options. There is also an option if you wanted to keep workloads on-prem for the foreseeable future. The reason for that is a lot of customers have workloads that are extremely latency sensitive, right? So you have workloads that require very high performance, and going to the cloud means you're not going to get that performance. There are also customers who have very, very specific data sovereignty needs, right? They need to keep their workloads somewhere close to them in some data center that they control, right? So for situations like that, we have a service called AWS Outposts. So Outposts basically is an extension of the AWS cloud in your own data center. So if you had use cases like that, Outposts can be an amazing way to move to AWS, but without having to move completely into the cloud. And we have a number of services also available on Outposts. So it's very much, basically it looks like what the cloud looks like, but with the infrastructure running in your on-prem data center. So let's talk about the two approaches I said, right? So if you're short on time, let's say you had a renewal coming up next month, and you need to make a decision very, very quickly, the quickest way to go about that migration is to do a lift and shift. So what we call this is so you migrate first, and then you optimize and modernize later, right? So get out of VMware, move into AWS, and once you are there, you can decide what you want to do with those workloads, right? So this process is very straightforward. It's being done for a number of years, as I said. So we can start with an assessment, which basically allows us to do a rapid discovery of the workloads you have in your environment. And then after that, we will set up a landing zone. We will help you with the lift and shift migration. And then once you're on AWS, you can optimize your workloads based on your business strategy that you have in your organization. We have a number of customers who have done this. Maiden recently rehosted 300 servers in a matter of 6 weeks. So it was very, very fast. 3M also migrated 2,200 applications in 24 months. And we're going to hear Claudio later talking about how they have managed these migrations themselves in a very recent migration that they did. If you wanted to go with a full migration approach, right? So in a full migration approach, your focus is thinking about the long term, right? So where do you want these applications to be long term, right? You're not just thinking migrate, you're also thinking about what is the ideal end state for these workloads, right? So a lot of people are saying, look, if I just bring workloads into AWS, that's great, but I want to leverage cloud native, right? I want to use containers. I want to use serverless. I want to take benefit of all the new stuff that's available in the cloud. So this approach really focuses on that long-term strategy. And again, this has 3 different steps, right? So we start with an assessment. And in the assessment, the focus is to figure out what is the business case of doing this exercise. Because this exercise is not fast, it takes time, but it provides long-term value for the business. So you need to really start by understanding what is the business case for this kind of an approach, right? For a full migration approach. So that's where we come in, we do the assessment, we figure out what the TCO is. Then we go through the mobilize phase where we create landing zone, we create detailed plans, we have training to upskill the IT staff in your organization. And then we go through the migration, right, using the tools that we have. And then once you are into the cloud, you can figure out what are the next steps you can take. And if you wanted to, as part of the migration, if you wanted to just modernize on your way in, that's an option available as well. Again, depending on the applications you have and the setup you have, this could take time. And that's why I think the thorough process really helps in the journey. I also briefly want to talk about Outposts. So Outposts is infrastructure, AWS infrastructure on-prem in your own data center. So it's a managed service. It's basically the exact same infrastructure we run in our regions. So we bring that over to you in your data center. We have 3 different products available. We have a regular rack, which is exactly what it looks like in the data center. So it's a 42U rack. We literally roll into your data center. It's fully configured, ready to go, right? So it's AWS services in your data center. And then if you wanted a smaller footprint, we also have two server form factors. One is a 2U server, and one is a 1U server. So essentially, it gives you the same AWS services, but in your own data center. So if you were looking at an AWS Outpost-based migration pathway, there are a couple of ways in which we can go about doing this. So the easiest way is to basically rehost your applications into Outpost. And the reasons why you would do that, again, as I was saying, if you have workloads that need to remain on-prem for any particular reason, this would be the approach you would take, right? So you would take your workloads, essentially rehost them on AWS Outposts, so that gives you basically access to critical services like EC2, EBS, ECS, EKS, if you wanted to put things on containers. And it allows you to basically seamlessly move workloads over very, very quickly. The second approach you could take is to re-platform these applications. And we have services like EKS, ECS, if you wanted to get into containers, that's an option available. So you can re-platform these workloads. We also have RDS available. So if you wanted a managed database offering to run with Outposts, that option's available as well. And then in the third pathway, essentially what you're doing is once your workloads are on AWS Outposts, you are thinking about what is the long-term plan for these workloads, right? So what this allows you to do is it allows you to get out of VMware quickly, get used to operating in AWS, and you can think about what is the long-term plan, and it gives you a little bit of time to really think about what that end state should be and how to plan for that, right? So these are just some of the options available on Outposts. One of the things that comes up a lot is the licensing implications and how do you handle that, right, as you're going through this migration journey. So we have a service called AWS Optimization and Licensing Assessment, OLA in short. What it does is when you start thinking about these migrations, we come in and we do a full assessment of your environment. So we'll take a look at all the setups you have, and then we will take a snapshot of where you are, what are some of the optimizations you can make, both in terms of licensing and also in terms of your actual infrastructure, and then give you a very crisp guidance on what's the best way to handle some of these workloads in terms of licensing impact. So this is, again, part of the assess process that we do as part of the migration. So that is all I had for the intro. I'm going to call Brian now on the stage, and Brian's going to talk about the different tools and services we have for VMware migrations.
Thank you, Mayur. So hello, everybody. So we're going to talk about, now that we've talked about the reasons to move your on-premises workloads onto AWS infrastructure, we're going to talk about some ways to actually do that. So I'm going to talk about 3 different services. The first is AWS Elastic Disaster Recovery, or DRS. The second is AWS Application Migration Service. And the third, we're going to talk about some third-party tools that can also help with migrations. So DRS is a AWS service that is used to create more or less, you could describe it as pilot-light type of disaster recovery. So you stage your workloads. They're continuously updated. And if you ever do have a failure in a primary data center, you can switch over to that backup very quickly. And then once the problem is resolved, you can fail over. So a pilot light sort of disaster recovery solution. And it's very flexible. So you can see on the slide that we can go from on-premise servers, they can be virtual, they can be bare metal, into the cloud or onto an Outpost rack. You can use DRS to go between Outpost racks. You can go from region to rack, and you can even go from other clouds to Outpost rack. It's a very flexible service, as I've just described. It can perform lift and shift type of operations. It's very reliable. It does continuous data synchronization until you decide to do a cutover and a final migration if you use DRS for migrations. It really doesn't have any great dependencies in terms of the source virtual machines or source systems, because it can be installed and used with any Windows or Linux system. And it's highly automatable, so you don't really require a lot of skills once you set up the disaster recovery and migration paths. So we're going to look at what that looks like for a typical cloud migration, or say a region-to-region pilot light type of deployment. So you start with a protected region. You have some number of source instances that you want to continue to maintain to make sure that you can have survivable over a disaster situation. And you decide you're going to build a pilot light or a DR site in another region. So what you do is you activate DRS, you go into Amazon and the console and the AWS console, and you build out the DRS service. So when you're building out that DRS service, one of the things that you do is you define a staging subnet, staging VPC and subnet, or they could all be in the same VPC, and then a recovery subnet. And once you've done that, you make sure that you have good connectivity between your source region and the destination region. Maybe that's through VPC peering, maybe it's through a transit gateway, as long as you have that ability to do connection between those two regions. So you've established that, and then DRS is an agent-based system. So you install a DRS agent on your source workloads. That DRS agent then registers itself with the DRS system or the DRS service. It then begins to replicate the source volumes from the systems that you've installed the DRS agent onto into the staging subnet. And it uses, we manage the instances that are created to perform that replication, but we begin to replicate those volumes through those replication servers into that staging subnet. Those volumes then are maintained. It's continuous block-based replication, and they stay that way until you decide that you need to use them for some sort of a disaster recovery. And one of the things I should mention is that when you use DRS, one of the things that it does is you can have point-in-time snapshots. So if you ever wanted to go back to, say, several points in time backwards, we maintain snapshots that allow you to specify your RTOs and RPOs. So we've migrated all the data to the region. We're maintaining it. We've created point-in-time snapshots. And if you ever do need those, you can do a cutover or a failover. And doing that, we create the recovered instances in that different region, in that recovery subnet. And that allows you to get back to where you need to be in a rapid fashion, and also over time, once you've solved the problem, you can go backwards. Okay, so what's that look like for migrating to Outposts? So we can use the same solution. In this case, we're going to use, if I can find a pointer there. There we go. So we're going to start with a location, say this is a factory or an on-premises data center, and we want to migrate that to an AWS Outpost. So you purchase the Outpost, and we work with you to figure out what that configuration needs to look like, what the size needs to be, and so on to support the workloads. You deploy the Outpost, and if you're familiar with the Outpost rack service, when you deploy an Outpost, it integrates with your on-premises systems through a construct called the Outpost Local Gateway. That local gateway connects to a customer gateway, and then that allows EC2 instances on the Outpost to communicate with anything that's on premises. In this case, DRS requires the use of EBS snapshots, and on Outpost, that requires the use of S3 on Outposts. So you've deployed the Outpost, you've got S3, you've got it connected into the rest of your on-premises network, you're good to go. So the process is similar to what you would see in a region-to-region disaster recovery. You stand up the DRS service, you create the staging subnet and the migration subnet in VPCs on the Outpost itself. You then install the DRS agents on any of those sources, virtual machines in this case, in the VMware environment. It registers with DRS, and then because you have a routed path between those on-premises servers and the Outpost, you can then begin to replicate, to do that continuous block level replication from the local on-premise workloads to EC2 instances in a staging subnet on the Outpost itself. Now in this case, because we're doing a migration, once all of those workloads have been fully replicated and you're ready, you can then create the snapshots for the point-in-time recovery that you're interested in achieving, and then do a cutover test, or testing an eventual cutover of those instances onto the Outpost migration subnet. At that point, you've moved those instances from your VMware environment onto the Outpost, and over time, if you decide you can back out those instances, you can decommission that on-premises VMware environment, and then you can disconnect those servers from the DRS. Okay, so that's the way you would go about using DRS to do a migration. There's a few things that you need to know. One, the Outpost server, as I mentioned, the Outpost rack has to have EBS and Amazon S3 in order to achieve this migration. The Outpost rack has two different modes of connecting between the on-premise workloads and the EC2 instances. One is called direct VPC routing. That mode is supported, and in that mode, the subnets that get created on the Outpost actually get advertised over BGP onto the premise. There's another mode called customer-owned IPs. In that case, you're actually giving us IP addresses from the premises to use on the Outpost. That mode is not supported. You have to, because we're doing replication of the on-premises workloads, you need to account for EBS storage for both the workloads that will remain in the end, but also the workloads that are going to be replicated over that migration period. And then you need to account for extra S3 storage if you're going to have a lot of point-in-time snapshots, because every one of those snapshots gets stored in S3. Okay, so that's DRS. The next we're going to talk about application migration service. Application, or MGN. And MGN is a very comprehensive tool that AWS has for migrating workloads from basically any source into AWS regions. And it's a very comprehensive tool. As I said, you can do a lot of automation. It provides consoles that can allow you to track migrations, and it can, once you've got those those applications migrated, you can then take advantage of all the applications and services that we have in the region. So it also, you might see, it has many of the same capabilities or the same features that we have with DRS, and that's because the back end uses a lot of the same technology. So the difference is that MGN is very tightly integrated into AWS Migration Hub, which is a solution that allows you to build out very comprehensive migration strategies. So AWS Migration Hub can allow you to pull a lot of people in from your organizations with different disciplines and backgrounds who have an understanding of how applications need to be moved over time into AWS, as well as pulling in partners, building out migration journeys, and so on. So MGN is the the tool that sits behind the migration hub that allows for those migrations to take place. So a lot of the same functionality in terms of actually moving the virtual machines from one place to the other that DRS has. So let's look at a migration journey using MGN. So we're going to start in the same place. We have a source data center. Maybe this is a factory. Rather than with DRS, we were showing coming from a region to region. And we define, we decide we're going to use MGN. You go into the AWS console. You create your MGN service. And that is very similar to with DRS in that you're going to create staging subnets or replication subnets, and then migration subnets, which are where you eventually want the migrated virtual machines to be. So one of the things that MGN has is this concept of launch templates. So you can define not only what you want your replication instances to look like, but also what ultimately the migrated instances will look like. And those are done through templates. So we want to make sure that we have good connectivity between our source network, our source site, and the AWS region. And that can be done over the internet. It can also be done over direct connections if you have a large enough facility to require that. So again, we install the MGN agent on the sources. MGN then begins to replicate those the volumes on those sources into the replication subnet, and it manages the creation of all the volumes and so on, and the scaling of those replication servers up and down. Once those volumes are created by MGN, we again do block level replication from the source to that replication subnet. And once they're there, you have the ability to do testing, test cutovers, and then ultimately do a full cutover of those instances into that migrated subnet, or the migration subnet. Now, how do we apply this to Outpost? So similar to with DRS, we have a factory or a site. We have a number of servers that we want to migrate onto the Outpost. But in this case, because AWS MGN is built to migrate applications and instances to the region, we stand up MGN, we create our replication subnets, our staging subnets, and our cutover subnets. We have the agent installed and the replication goes from the source into the replication subnet. And then to get it to the Outpost, we do things a little bit differently. We'll go ahead and do a cutover of the source instances and source volumes. And once that's done, we'll go ahead and create an AMI, an Amazon machine image, from that volume, from that cutover volume. You can then use that Amazon machine image to deploy a new instance onto the Outpost on premises. So you'll see it kind of makes a trip through the region, unlike what we saw with DRS. But that is a way of using MGN to do a migration to an Outpost. And it's attractive to people who are using MGN for other purposes, maybe doing other cloud migrations to regions. And it's a common tool, a familiar tool for them to use. OK, now third-party tools. We've been doing a lot of work recently with a partner, Cirrus Data. And Cirrus Data has a multi-source, multi-destination migration tool called Cirrus Migrate Cloud. They also have a similar product that can do all on-prem. But they're an any-to-any migration tool. But as I said, they've done a lot of work with us to make sure that that product works very well with AWS Outposts. It's a SaaS platform. And it allows you to do a migration on-premise directly from a VMware environment onto Outpost without a trip through the region and without any dependencies on S3 on the Outpost. And some customers prefer this type of a migration scenario. They charge by the terabyte. So if when you get a license from Cirrus, they basically say, hey, you want to transfer 10 terabytes of data, it costs this much, and you're off and running. So once you've signed up for a Cirrus Data account, they have a very solid integration with AWS. You can provide an integration either using your AWS access keys and secrets or through AWS IAM roles. So you create an account, you apply your license, you then create your integration with AWS, and you're now ready to begin to migrate between the two. So what that looks like, just like DRS and with MGN, you do an agent installation. And that installation installs an agent on the virtual machines that you want to transfer, and that can be managed through something like Ansible or whatever other tooling you have on premises. It registers those virtual machines with the Cirrus Data SaaS. And at that point, once the Cirrus Data Platform understands and knows about the sources, you have the ability to create a migration operation. And with Cirrus, the way you do that is through the creation. Now you can do it, there's a way to do it in their UI just by going in and doing it manually. But they have a part of the solution is called migrate ops. And with migrate ops, you define basically through YAML a definition that describes how you want to migrate the source onto what ultimately is the outpost, because the source and destinations are defined A, by the source registration, and B, by the subnets that you specify where you want the instances to go in the end. So you define this migrate ops scenario, and you push it into, via YAML into their platform. And at that point, the SaaS platform creates a helper agent on the outpost itself. And that helper agent is used to actually transfer the data directly from the source in your VMware environment through the local gateway into the subnet on the outpost. And while that's happening, this transfer, by the way, takes place over TCP. And one of the special aspects of this is as long as you have routability between the on-premises environment to the outpost over that LGW, that's the direction that the migration takes. So it doesn't have to go to region, doesn't have to use anything special like creation of AMIs or creation of snapshots and so on. So once a session is created, you can monitor it in that SaaS platform. You can see how much data has been moved, how long it's taken, and so on. And once that data is fully synchronized between the source and the volume that the helper agent is using, you get the request to approve the cutover. Once you approve the cutover, the platform creates the actual target instance. It adapts the volume that has been migrated so that it's bootable by EC2. And then at that point, it attaches that volume and launches the instance. And everything that I just described that takes place in the UI also has an equivalent in a RESTful API that you can use. So this platform is very well suited to migrations, especially if you have some GitOps background or some GitOps pipelines that you can leverage against this. Okay, so I've described 3 different migration pathways. The first, DRS, basically you want to use if you're already using it, and if you have a desire to do a migration to an outpost where you have S3. The second is AWS MGN. That's a good choice if you're already using a MGN to do other migrations, maybe full-scale cloud migrations and so on, and you can continue to leverage that tool to move workloads from on-premises onto Outpost. And then the third is a third-party migration tool. I just described Cirrus. There are others. There are backup companies that have the ability to do like a local backup and deploy that onto AWS as well. So those can all be considered. Okay, quickly, I'm going to talk about one of the migration pathways that Mayor spoke of earlier. In this case, it's a replatforming migration. So we have worked with a large banking customer in South America, and they deployed a large number of Outpost to solve a problem that they had where they needed to keep workloads on premises. And the reason they had to do that is they had an enormous mainframe database that was really the back end for all of their banking applications. They were running Kubernetes. They had modernized part of that to Kubernetes, and they were running that on top of a VMware environment. But they also had some number of virtual machines that were providing queuing services and other application services that had to access that back-end database. So what they decided to do, they wanted to modernize and move to an Outpost-based solution so that they could integrate better into their full AWS estate. And what they did was they re-platformed onto EKS on Outpost. So they already had a large number of Kubernetes-based applications. Those, because of being Kubernetes, could move into EKS fairly straightforward. But then they re-platformed the queuing and the other applications that had previously been virtual machines and modernized those so that they were containerized and could also run on Kubernetes. All of that ran on an Outpost, which was close to that mainframe database for latency purposes. And at that point, they weren't going to modernize the mainframe, but at least they did a re-platforming onto AWS Outposts. So Claudio is going to talk about a different path. That's going to be the rehosting pathway. Thank you.
Thanks, Brian. Hello, everyone. I hope you are enjoying the session. So in the next 20 minutes, I will walk you through to our cloud journey and how it enables us to migrate our first factory into cloud. A quick background about BAT. So we've been in the tobacco business for more than 120 years, and we have a global operations in more than 108 countries with more than 52 employees, and we are committed to deliver throughout our new products categories, such as vaping, modern oral, and heating tobacco. So I want to go through about the drivers, because Mayor already covered in the beginning. So let me take a quick step back and tell you how our cloud journey started. So it always started around 10 years ago when we started migrating small workloads to the cloud, non-critical workloads, non-factor workloads to the cloud, until we reach a stage where 100% of our workload were already in the cloud. However, we have around 50 factories around the globe, and all those factories, we have at least one data center. And each time we reach out those factories, engage with them to see a potential migration to cloud, we always get a pushback. And most of the time, the reason were the same. Or they would say, well, our system requires low latency because they are connected to PLC's device, connect all the machineries. In some case, because there was old application and those applications were not designed to run in the cloud. Or even we have factory in some location where the internet is not reliable. So those are really good questions that need to be considered. So exactly 2 years ago, I was having a meeting, a service review meeting with AWS team, and we were discussing our strategy, and I was talking about all the challenges we were having with those factories. And then they said, well, no worries, we have a perfect product for you guys. It's called AWS Outposts. I said, well, Outposts, never heard about. So anyway, so they explained all about Outposts, and I won't go through the details. Mayor and Brian already covered that. But then we liked the idea. We saw that it could be a good fit for our factory. So we brought us that idea to our head of our cloud and data center area and explained to him. And he also liked the idea and gave us the go-ahead to see which factory we could start. He just said to me, I have 2 requests if we are going into the journey. So the first one, you have to be the project manager. because this will be a very critical and very strategic project for the organization. And the second question, he said, well, don't screw up, because we only have one chance to get it right. Otherwise, we won't have another chance to migrate those factories. So that's what we did. We chose a factory that we had some influence, where we were nearby as well to manage the project. And we engaged the conversation with them. It wasn't easy, I won't lie, because they didn't know. So we had lots of different rounds of conversation. And in the end, they agreed, but they said, well, we have one request. So if the product is that good, and if you guys can deliver what you are saying you can deliver, so you should start with our most critical system. That's our MES system, because if you can migrate the MES system, the critical system, I'm sure you can migrate all the other systems. However, if you fail quick, and we don't spend money, we don't spend time with the rest of the system. We send back this hardware to AWS, and we keep as is. And I said, yes, sir, let's do it that way. So here you can see the architecture of our MES system. So it is all Windows-based, and we were running on VMware. We had a Microsoft SQL cluster that we moved to Outposts. We had to do some slightly change, because some the sharing storage is not supported in the same way in the Outposts as it is on VMware, for instance. So we moved to Microsoft SQL always on, and we were able to keep the same functionality and the same high availability that the business were looking for. And going one level above, we had two Windows failover clusters, one for the application and one for the machine integrator. And here we had a bit of more challenges, because again, AWS doesn't support native in the same way Windows failover cluster as we had on VMware, where we have a virtual IP on top of the cluster. So to overcome that challenge, what we did is we leveraged using of a PowerShell script that what does is whatever the active node goes down, the Windows failover cluster will call that script, and that script will call an API in the region, and it will move the IP address from the active node to the passive node and vice versa, and then the passive become an active node. And so pretty much the same with some small change, but we kept the same functionality, the same high availability with one caveat. As I mentioned, so this PowerShell script need to call an API in the region. So you must have internet connection for that failover to happen. Going one level above in the web service layer. So we have two web services with a load balancer, a Windows load balancer, a Windows NLB using DNS round and robin. So NLB is not supported on AWS, so we shift to AWS ALB. And here, another caveat or another consideration that I will anticipate already, one of my top for my lessons learned. In our NLB, we were using a stick session, and it turns out that stick session was not supported by AWS. Or let me phrase, a stick session, it is support in the region, but it's not support in the outpost. So we had to change the behavior of our web services to move to active and passive node, and with the help of a Lambda function, along with ALB that keeps monitoring the health of the web server, we were able to deliver, again, the same functionality and the same high availability that the business were looking for. On this slide, I like because we can see a huge simplification. On the left side, what we had on premises, lots of different contracts, hardware support, VMware license, backup license, tape management, and all those contracts. Now we had one single line, AWS Outposts. And we didn't even have to do a contract because the Outpost is already part of our enterprise agreement on the network as well. Of course, we had to do the setup, but we didn't have to do any upgrade or any bigger change in the network. On the support as well, so we switched from the vendor that was support on premises to the vendor, to our partner that was already supporting us in the cloud. And in the end, we had 45% of cost saving. That was huge for the business. So let me jump into the lessons learned. There are quite a few lessons learned. It starts from the very beginning, ordering. You might be thinking, well, ordering is just an ordering. And yes, however, you need to pay attention a lot on the requirement because AWS will ask you a ton of questions in order to place the order. So they will ask, how is your data center floor? How much weight your data center floor can take? Where are your network cables and your power cable coming from the floor, from the ceiling? How is your cooling system? How is your internet? And so many other questions that usually we don't have in hand to answer and can take some time to get all those questions. And you need to have that to place the order. And the delivery, again, you might be thinking, well, we are used to receive goods in our data center all the time. Yes, I agree. However, the Outpost will come fully assembled, and it will come inside of a cage. So you need to have a proper space to deliver that cage or that Outpost inside of your data center. And AWS is very restricted in the process who can even touch the Outpost. So be mindful of that. Installation, ensure that, like in our case, our data center is inside of the factory, so the engineers need to go through several security training to be able to work into the data center, so it can take some time as well. The collaboration, this is one of key parts I see in the project. So the way we did, we create a plan and we start socializing in the very beginning, all the stakeholders, all the application owner to explain first what was the Outpost, why we were doing the project, and get them on board on our side, as well as document everything. Because we know that sometimes there are some people, they tend to forget something they have already commit, so it's very important to document everything. On the connectivity side, it's very important to plan at least one workshop with AWS, with your network team, cybersecurity, or your cloud team, to understand all the Outpost requirements, to understand all your network design, and so on. Like what Brian mentioned before, the communication between the Outpost and the local network, it's via BGP. We were not using BGP. It's not a very common protocol, so we had to enable that. And in some cases, you even need to get a license in your switch to enable that feature. On the communication, so it's very important to have a dedicated PM, especially if you are dealing with a factory that's operate 24/7. So you need to have a project manager that will engage all the stakeholders, all the different teams. We also had teams in different time zones, like US, Mexico, Poland, India. So it wasn't easy to get everyone together. On the constraint side, so again, it's very important to understand what are all the requirements and all the constraints, not only in the application, but also from the AWS side. On the network, again, so very important to do an end-to-end test. not when you are doing the migration, but when you do the setup of the outpost. So it will avoid you to have lots of issues during the UAT. In our case, on the UAT, we had to take a step back and review some network design. After that, we were able to continue with all the migration. On the load balancer, as I mentioned, it can be a very simple topic, but it has its own challenge as well. So it's very important to understand the requirements and the capability of the load balance that you have and what you are planning. On the migration, this is very important as well. So first, define the migration approach you are taking and see what tool are you going to use. In our case, we decided to go with the AWS migration services, the MGN that Brian already mentioned. However, before we start, no one told us that to use MGN with the Outpost, it had to be we have to have S3 in the Outpost. So we started the first migration and we were having lots of issues and were failing. Then we find out that we had to have S3. We didn't have. We only had EBS. So the workaround is what Brian mentioned. So we had to take the workload to the region, and from the region create an AMI and download in the Outpost. So it did increase the time for the cutover, and of course it increased the cost while those workloads were running in the region. Placement. It's not because you are ordering Outpost that all your workload from on-premise need to go in the Outpost. So we did a very deep analysis in all the application, and we found that some application, it could go direct to the region. So we kept in the Outpost only what was really required, mainly regarding those low latency issues. Last but not least, IP addressing. So be prepared for new IP address ranges. Although it is possible to move your subnet, your VLAN from VMware to Outposts, depending how it's been configured. And we, in some cases, we did that, but it is very painful because the same subnet cannot reside in both places. So once you migrate that subnet to the Outpost will become your gateway. And so if you have, let's say, a server and a network device in the same subnet, you will need first to remove that factory device from the subnet, then you can migrate the server. And if you already have all segregate, it is much simple. Let me go through some key benefits that we saw after this migration. So infrastructure as a service. We no more need to take care of hardware, buying hardware, doing a hardware refresh. So we can focus in our core business, and we let AWS to deal all those hardware things. Simplify resource scaling. So very easy to scale an Outpost, and we had an experience in the middle of our project. There was a new requirement from the business to increase the capacity. And if it was in our old data center, it probably would take us a couple of months to get a new server and all the new capacity available. In the Outpost, we placed an order with AWS, and in a couple of weeks, the new capacity was available in the Outpost. So it was really good experience. A very consistent management experience. So we have one single vendor, we have one single console, so everything is in the AWS console. If I need to deploy a new server, if I need to take a backup, whatever I need to do, it's one single console and one vendor. Of course, reduces cost and complexity, as I mentioned. So it's one single pane of glass. The same tools we were using in the region, we are using the Outpost. As Mayur or Brian already mentioned, so the same infrastructure AWS has in the region, now we are using on our premises. So it's very resilient. It came fully redundant because it is designed for mission critical. Cloud-based backup and disaster recovery is now possible for us. In this specific data center, we didn't have a very good disaster recovery plan. Now, all the Outpost backups, they are stored automatically in the cloud. So you can make a cloud DR within minutes. And a lift and shift migration, that the choice we choose, and was, I wouldn't say straightforward, but we didn't have to do any application reinstallation. So leveraging the use of the tool that we already mentioned, we were able to migrate all the workloads.
I think we're just about out of time, so we'll be here. If you have any more questions, we'll be happy to take them offline. Okay. Thank you, everyone, for coming. Really appreciate the time.